Hello dear students, I hope you all are fine and doing well in your studies. So students, in this chapter of sequences and series, we have covered all the topics that are asked in the examination. And we have understood with the help of various examples and illustrations how to solve or approach a question when it is being asked from this chapter. So students, now in this particular lecture or session, we will be doing some miscellaneous questions. Why miscellaneous? Because it will be consisting of the questions which will be of collective form of all the topics that we have studied so far. It will consist of questions from AP, from GP, from arithmetic means, geometric means and sum of series. So students, without delaying further, let's get started with today's lecture. So the first question over here asks us the sum of sigma r varying from 2 to infinity 1 by r square minus 1, and this is equal to which one of these options. Alright, so this is basically a question that is based on series summation. So let's begin with the solution part. See, first of all, if we carefully observe the general term of the series which has been asked, so the general term is written as 1 over r square minus 1. So now we will have to manipulate the general term. And how do we manipulate it? Let me show you. First of all, we are going to write down the factors of denominator, which are r minus 1 and r plus 1. Alright, using the identity of a square minus b square, which is equal to a minus b and a plus b. So now, in such type of general terms, how do we manipulate the numerator? We write down the numerator as the difference of the terms at extreme, and the terms at extreme are r plus 1 and r minus 1. So basically, the numerator will be written as the difference of these two, and the difference of these two is going to be r plus 1 minus r minus 1. But the problem is that when we subtract r plus 1 and r minus 1, we are going to get 2, but over here there was 1. Here we are getting 2, so we are dividing this quantity by 2 so that the mathematics is balanced. And now we have r minus 1 and r plus 1 in the denominator. So one should cleverly be able to write down this expression or this general term in this way, such that we can now split them up in the difference of two terms. Alright, so now if I split them up, r plus 1 when divided by r plus 1 gets cancelled off. So we are left with 1 by 2, 1 over r minus 1 minus r minus 1 gets cancelled off with r minus 1. So this becomes 1 upon r plus 1. So this is the way in which we have to split the general term in order to arrive to the answer of such kind of questions. Alright, I hope everybody is getting till this point. So now from general term, in order to determine each and every term, we will have to substitute the values of r. So for the first term, r is going to be equal to 2 because the series summation is starting from r equals to 2. So corresponding to r is equal to 2, we are going to get t1. So t1 becomes 1 by 2. Substitute r is equal to 2 over here and r is equal to 2 over here as well. So this becomes 1 minus 1 by 3. So similarly, if we put r equals to 3, we are going to get second term, which is t2, and t2 becomes equal to 1 by 2 minus 1 by 4. Similarly, if we substitute r equals to 4, we are going to get t3, and this is equal to 1 by 2 times 1 by 3 minus 1 by 5. Alright, similarly, when r is equal to n minus 1, we are going to get t n minus 2th term, and this is equal to 1 by 2 1 over n minus 2 minus 1 over n. And when r is equal to n, we are going to get t n minus 1 as 1 by 2 1 by n minus 1 minus 1 by n plus 1. So now what we are going to do is we are going to add them up. we are going to add t1, t2, t3, tn minus 2 and so on till tn minus 1. Alright, which means that we are adding all the values corresponding to r is equal to 2 till r is equal to n, and then we are going to substitute n approaching to infinity so that we can get the terms of this series consisting of infinite number of terms. So over here, if we add all them up, we are going to get Sn minus 1, and this is equal to what? 1 by 2. When we add these terms gets cancelled off. 1 by 3 gets cancelled off, and then 1 by 4 with this term, and then 1 by 5, these terms will get cancelled off, and alternatively these terms will also get cancelled off, and this cancellation will be done in a diagonal way in the same fashion. So over here we are left with 2 terms, and over here also we are left with 2 terms. So these 2 terms add up to give us 3 by 2, and these 2 terms add up to give us minus 1 by n minus 1 by n plus 1. And now since we are interested in finding the sum of infinite many number of terms, so basically n approaches infinity in this particular series. So when n approaches infinity, this term vanishes and this term also vanishes, because 1 divided by infinity will approach to 0, and this will approach to 0 in a similar fashion. So the answer comes out to be 1 by 2 multiplied by 3 by 2, which is equal to 3 by 4. So the correct choice corresponding to this question is choice B, and this is 3 by 4. So I hope everybody must have understood this problem and must have been acquainted with the technique in order to solve such series in which the general term can be splitted as difference of 2 terms, so that the terms gets cancelled off in a particular fashion and the calculation becomes very simple in order to arrive till the answer. So let's move forward and see our next question. Next question says, the fourth power of the common difference of an arithmetic progression with integer entries is added to the product of any 4 consecutive terms of it. Prove that the resulting sum is the square of an integer. So let's begin with the solution part. So now in this question, we have been mentioned about the 4 consecutive terms of an arithmetic progression. So I am considering those 4 consecutive terms to be a minus 3d, a minus d, a plus d, and a plus 3d. Let these be the 4 consecutive terms of an AP. Alright students, one must take a note that if they are in AP, the common difference can be obtained by subtracting either these 2 or these 2 or these 2. So the common difference over here is going to be what? It is not equal to d, in fact it is equal to 2d. This is the common difference of these terms in AP, and the first term that I have taken is equal to a minus 3d. So now the demand of question says the fourth power of the common difference, that is 2d raised to the power of 4, is added to the product of any 4 consecutive terms of it. So we have to multiply these 4 terms. So upon multiplication, this gives us a minus 3d multiplied by a minus d multiplied by a plus d, which is further multiplied by a plus 3d. And fourth power of the common difference is being added in this quantity. So fourth power of common difference means 2d raised to the power 4. And now that we have to show that, prove that the resulting sum is the square of integer. We have to show that this resulting sum is going to be a square of integer. So now let's move on to the simplification part. We are going to club these 2 terms together and these 2 terms together. So this becomes a minus b into a plus b, which gives us a square minus 9d square. And again over from these 2 terms, we are going to get a square minus d square using the same identity of a square minus b square. And 2d whole raised to the power 4 becomes 16d raised to the power 4. Alright, now let's multiply each and every term. So we get a raised to the power 4 minus a square d square minus 9 a square d square plus 9 d raised to the power 4 plus 16 d raised to the power 4. So this gives us a raised to the power 4 minus 10 a square d square plus 25 d raised to the power 4. Alright, upon simplification we have arrived till this part. Now one can observe that this can be written as a square ka square minus 10 a square d square can be considered as 2 into 5 into a square into d square plus 25d raised to the power 4 can be taken as 5d square ka bhi square. Alright, so we are getting a square plus b square minus 2ab. Alright, a square plus b square minus 2ab. So this becomes perfect square of a square minus 5d square. Alright students, so this entire expression upon simplification, this becomes a square minus 5d square ka whole square. Now since the terms of these AP were integral, so a and d were also integral, so a square minus 5d square is also going to be an integer. So hence proved that this result is nothing but a square of an integer. Alright students, so this question has been asked in IIT JEE examination and I hope everybody must have understood it. Let's move forward and see our next question. It says the continued product of three numbers in GP is 216 and the sum of the products of them in pairs is 156. Find the numbers. So let's begin with the solution part. So since we have been mentioned about three numbers in GP and the continued product is given, so as I have already told you that you are going to consider the terms as A by R, A and AR. These three terms are continued terms of GP where common ratio is equal to R and first term is A by R. So the product over here is given to us as 216. So this gives us a cube as 216 which gives us the value of a as 6. So a becomes equal to 6 and sum of the products of them in pairs which mean a by r multiplied by a plus a multiplied by ar plus ar multiplied by a by r. This is the meaning of this statement. Sum of the products of these terms taken in pair, this is given to be equal to 156. Alright students, so this becomes equal to a square multiplied by 1 by r plus 1 and this is 156. Now since the value of a is known, we can substitute over here. This becomes 36 and 156 further gets divided by 36. So basically now we have 1 plus r square plus r divided by r is equal to 156 divided by 36. So now we have to calculate. So this goes 6 times and this goes 26 times upon division by 6. And now upon further division we can have this as 3 and this as 13 since 2 is the common factor of 26 and 6. So this leaves the fraction of 13 by 3. So basically upon cross multiplication we are going to get 3 plus 3r square plus 3r equals to 13r, which gives us a quadratic equation in r as 3r square minus 10r plus 3 equals to 0, which can be factorized by splitting the middle term as minus 9r minus r plus 3 equals to 0. So take 3r as common, we are left with r minus 3 minus r minus 3 equals to 0. So r minus 3 into 3r minus 1 equals to 0, which gives us the values of r as 3 or 1 by 3. So r can be equal to either 3 or 1 by 3. Now we are done with the values of a and r as well. So now we were asked about the numbers and numbers were a by r, a and ar. So if I consider a equals to 6 and r equals to 3, the first term is 6 by 3, which is 2. Second term is a itself, which is 6, and third term is ar, which becomes 18. If I consider a equals to 6 and r equals to 1 by 3, so the first term is a by r, which is 18, second terms become 6, and third term becomes 2. So the terms or the numbers are 2, 6, 18 or 18, 6, 2 corresponding to this particular question. Alright students, so I hope everybody must have understood this particular question that was based on the terms of a geometric progression. Let's move forward to see our next question. Next question says, if the pth, qth and rth terms of an AP are in GP, find the common ratio of the GP. So let's begin with the solution part of this question. फर्स्ट टर्म कैपिटल ए है और कॉमन डिफरेंस कैपिटल डी है. Alright students, so we are supposing the first term of the arithmetic progression to be capital A and common difference is capital D. So pth term, which means TP, and TP becomes equal to A plus P minus 1 into D. Qth term becomes A plus Q minus 1 into D, and rth term becomes a plus r minus 1 into d. And these terms have given to be in another progression, which is geometric progression. So now let us consider that the terms of geometric progression are alpha, alpha r and alpha square, where alpha is the first term of geometric progression and r is simply the common ratio of geometric progression. So we can equate these term as alpha, this term as alpha r and this term as alpha r square, because these are in GP and these have been given to us according to the question that they are also in GP. Alright students, so we are required to find the common ratio of these GP, which means we are interested in finding the value of r. So let us first name these equations as 1, 2 and 3. If I subtract equation number 1 from equation number 2, what we can get? 2 minus 1 will give us, this gets cancelled off a, and q minus 1 minus p minus 1 gives us q minus p multiplied by d, and in RHS we are going to get alpha r minus alpha, which is equal to alpha multiplied by r minus 1. Alright, so similarly we are going to subtract equation 2 or relation 2 from relation number 3. So 3 minus 2 gives us, in LHS this a gets cancelled off, and upon taking d as common and performing the subtraction, we are going to get r minus q. R minus q times d is equal to alpha r square minus alpha r. So take alpha r as common and we are left with r minus 1. So now let us consider this to be equation number 4 and this to be equation number 5. Now in order to determine the value of r, what we are going to do, we are going to divide these two equations. So 5 divided by 4 gives us what? R minus q into d divided by q minus p into d. And in RHS, we are going to get alpha r into r minus 1 divided by alpha into r minus 1. Now alike terms gets cancelled off and we are only left with r over here. So r simply comes out to be equal to r minus q divided by q minus p. And please make a note that this r over here represents the common ratio of GP, while this r over here represents the r that was mentioned in the question over here as the rth term. So please don't get confused with these two r. This r has been mentioned according to us as common ratio, and this r, smaller r, is the r mentioned in the question. So common ratio comes out to be r minus q over q minus p. Alright, I hope everybody must have understood this question also, which was based on the terms of GP and AP as well. So let's move further and see our next question. Next question says find the sum of n terms of the sequence and the sequence has been given to us like this. So let's begin with the solution part. Find the sum of n terms of this sequence. We are first going to write the general term. Let us consider it to be TR, and TR will have in numerator as 1 because in each and every term numerator consists of 1 only. So we have to think upon the denominator only. In denominator we are getting continued product of 3 odd numbers. See, 135, then 357, then 579. So over here in general term we are going to get 2r minus 1, then 2r plus 1, and then 2r plus 3. Because the general terms of an odd number is given by either 2r minus 1 or 2r plus 1 or 2r plus 3. So we are starting with the lowest one and then we keep on increasing, and these are the three numbers. One can easily verify that when we substitute r equals to 1, we get t1. In denominator we get 1, 3, 5, and t1 is given to be 1 divided by 135. So our general term is completely correct. Alright, now since I have already told you that such type of questions are dealt with splitting up of terms so that we can add them up and terms gets cancelled off diagonally and simplification becomes much easier. So in order to approach this question in that particular fashion, we will have to write down the numerator as difference of the terms in the denominators at extreme. And at extreme we have 2r plus 3 and 2r minus 1. So we are going to write down their difference. So tr becomes 2r plus 3 minus 2r minus 1. But their difference comes out to be 4. So in order to balance the equation, we have a 4 in the denominator as well. In denominator, we are going to get 2r minus 1, 2r plus 1, and 2r plus 3. Alright students, so again we have manipulated the numerator as the difference of terms at extreme. So this becomes equal to 1 by 4. Upon splitting up or upon separation, 2r plus 3 gets cancelled off, and here we have 2r minus 1 multiplied by 2r plus 1 minus. Here we have 2r minus 1 gets cancelled off and we are left with 2r plus 1 multiplied by 2r plus 3. So this becomes TR. Now our calculation part is going to be much simple as we kept on substituting the values of r. If r equals to 1, we get equals to 1 by 4, 1 upon 1 into 3 minus 1 upon 3 into 5. If r equals to 2, we get t2 as 1 by 4, 1 upon 3 into 5 minus 1 upon 5 into 7. And r equals to 3 will give us third term as 1 by 4, 1 upon 5 multiplied by 7 minus 1 upon 9 into 11. Alright, and this continues till r is equal to n, so that we can get the nth term as 1 by 4, 1 upon 2n minus 1 into 2n plus 1 minus 1 upon 2n plus 1 into 2n plus 3. Now in order to get the sum of the series, we have to add each and every term of the series. So if we add them up, this gives us sigma Tn, r is equal to 1 to n, and which is equal to Sn. And in RHS, if we add them up, what is going to happen? These terms gets cancelled off. And we are left over here as 1 upon 1 into 3, which is 1 by 3. And over here we have 1 upon 2n plus 1 into 2n plus 3. So in all, we get 1 by 4 times 1 by 3 minus 1 upon 2n plus 1 into 2n plus 3. So this is the required sum of n terms of this particular sequence. So students, I hope with the practice of such questions, you people are much more comfortable now. So students, this is it for today's lecture. we will continue and finish this chapter in our last lecture of sequence and series, in which we will be covering the questions of previous years that have been asked from this chapter. But this is it for now. See you in the next lecture. Thank you.